supposed to be doing. Okay, that there. This says I got 30 minutes, so I better talk fast to finish this lecture right there. So, okay, that there. Actually, my goal is to get through the second chapter. We won't do a program today, but we'll do one next week. Now, next Friday, there will be no class. I think I announced that already, but I just want to remind you that, and I'll put something on Facebook, but don't show up next Friday, okay? That there. So, that there. Okay, let me just kind of jump in here and talk about, all right, we already did this project right there. And I moved my computer and, that there. See, now we got all four of us up there. Perfect attendance. Makes life easy. Although, out there. Okay, we already did this program last, on Tuesday we met, right? Yeah, we meet, what, Tuesdays and Fridays, or is Wednesdays and Fridays? What? Tuesday, Friday, okay. Yeah, you're one of my first classes of the week and one of my last classes. I have another class at 3 this afternoon, the robotics class, so that there. Yeah, so I've got that class at 3 o'clock. Okay, in this particular one, at there, and this is the, this is the one that we did, and I just want to kind of review a few things from it because that leads us into the next one. We declared 3 variables here. Number one, number two, and sum. And I think when I did the lab, I just called it num1, num2 right there because I don't like typing. That there. I'm a good typist. I learned typing many years ago, back when most people didn't learn how to type because this was pre-computers. That there. Typing is a valuable skill if you're not a proficient typist. Although I tend to think now the replacement skill is being able to use your thumb on the text keyboards, right? That seems to be the more important skill for anybody under the age of 25, that there, but regardless. So we've got these 3 variables right there. And these are temporary locations in memory right there. And we can place in them any value we want as long as it's an integer in this case, right there. So we're only using integers in this particular case, right there. Now, because it's an integer, one of the things here is that our command here for output right here is we just send it a string. This is a string right here. And a string is an array of characters right there. So this is a string. And some people will call it strings. Some compilers will use strings. Some will use char like this with an empty bracket like that there, which means that it's an array of characters. Because that's what a string is, right there. So that there, it's a series of characters. The characters is a 8-bit number that represents a letter or a symbol in the Unicode table, which includes all the letters A through Z, numbers 0 through 1, all the punctuation marks, and then the extended, that's the ASCII table, then the extended will include things like plus, minus, because the plus and the minus signs are in the standard ASCII table, but the plus minus symbol, the one that looks like this, plus minus, like that, is not. And that's in the Unicode set, along with a lot of the Arabic characters, some of the Greek characters. In other words, you don't see the character pi in the ASCII set, but it's in the extended ASCII set. And I still call it the extended ASCII set. I think the proper name for it now is Unicode, but when it first came out, it was just referred to as the extended ASCII set right there. So, but we've got those variables. The rest of this program is fairly straightforward. We use our standard library function, cout and cin. And since they're in the standard library, we have to put the standard in front. Out there. Everything else in this is fairly straightforward. We put a prompt, we read the number. We put a prompt, we read the number. The number is stored in this location. So whatever comes from our input console is then stored in our memory location right there. So in this particular case, whatever's stored in sum is sent to my output console right there. See out right there. So the rest of this right there we've already done. I just kind of wanted to hit the highlights of what happened up there, because Right there. Now, again, we also have, leading into this right here, is that they talk about declarations produce identifiers in the program. These are variable names. So we will refer to these as variables. And that there's another type of data there. It's called a constant, which we would define in the beginning of our code or function. And a constant remains the same, and we can't change it. For example, a constant in our code, if we're writing a program to calculate the price of beef burgers that are at a local stand, and that's a project I gave last semester. I'll probably give it as an interim project here, where you have to write a little thing to, run a burger stand, where you got 5 different types of burgers or whatever and you have to calculate GST. Well, GST is currently, 6%? There. Well, we could be like Singapore, it might become 7% next week. There. Or we could be like California and become 12%. There. I lived in the UK back in the 1970s and it was 25%. There. So it was quite, they called it VAT then, value added tax, which is the same thing as GST. But it used to be called VAT. And the old British system is that if you bought something and it was considered a luxury item, the VAT was 12%, or 12.5%. Not luxury, a necessity item. If you bought something that was considered a luxury, the VAT was 25%. Well, back then, radios for tape players was considered a luxury. In other words, if you had a cassette tape player, which no one's seen a cassette tape player in this class because they've been obsolete for at least a decade. They were replaced by the CD player, and now they're replaced by the MP3 players or the iPods. And the iPods have been replaced with the iPhones or the cell phones with MP3 capability. But I've gone through every generation since vinyl records This last 50 years has been, and this is kind of a side note, the last 50 years has been such a change in technology over the previous 2,000 years. Technology has changed more in the last 50 years than the previous 2,000 years. If you go back 50 years ago, when I was 10 years old, black and white TV was the norm. Color TV was invented, but very few people could afford it. Vinyl records was the norm for music recordings there. And the vinyl record was invented in the 1860s, 1870s. So that tells you how long the vinyl record stayed around. Then the vinyl record was slowly replaced with the cassette. The 8-track was out for a while. Then the CD player. Then the CD player has been replaced. So all these things, there's been 4 iterations in the last 50 years. And previously, the previous one was the vinyl record, and that lasted for over 100 years. So that tells you how fast technology has changed. Television, when I was a 10-year-old 50 years ago, you had an aerial antenna. There was no cable TV. There was no video, there was no video files, none of that stuff. There was no cassette recorders. You watched 3 channels that was produced locally in black and white. Now you look at television, and you've got these 60-inch, 84-inch high-definition TV. Now it's the ultra-high-definition TV, and you can stream 300 channels from around the world over the internet. You can save things on a thumb drive and stick it into your TV set and watch that. So everything's changed there. So by getting back to this right here, declarations, we have 3. They're integer types. All variables must be declared with a name and a data type before you can use. So if you're going to use any variable, you have to declare it before you use it. Now, good programming techniques, and that's a very key term, the idea, good programming techniques, is that you declare all your variables at the beginning of your function, or if they're global variables, you declare them outside your functions at the beginning of your program. They're new generation programmers that are somewhat lazy, and I find a lot of students will do this, will declare a variable just before they use it. They're writing their code, they realize they need a new variable, they declare it in the middle of their code. that there, and they don't put it up at the beginning. And that's perfectly legal. The language lets you do that, but you could get yourself into a lot of trouble doing that. And the reason you get yourself into a lot of trouble declaring them midstream, right there on the fly, is the way that I use it. Is that you forget that you've already declared it, and now you're redeclaring it again. That there. And sometimes you end up declaring the same variable name 3 or 4 times. That there. So it's best to just declare them all at the beginning of the function. That there. So, but again, you can declare multiple variables on the same line. Going back to my code here, I said right here, I could have, instead of these 3 lines right here, I could have just said int num1, comma num2, 2 comma sum, right there. And I could put the equal zeros in there as well, right there. I don't have to have 3 separate lines. And I'll be quite honest, I typically would probably do this as one, and I probably wouldn't bother initializing them. Right there, you don't have to initialize them. That's up to you, right there. It's a good habit to initialize it. This is the area where I say good programming techniques, and I stress one. And here's one that I'm lazy with. Right there is I don't always initialize it because I make sure here whatever I initialize num1 to, before I use num1, I'm going to re-enter it. So it's going to be, so it's initialized when I read it from the console, right there. And I'm not using it for anything ahead of time. The reason people attempt to initialize it because it has a random value there. And I'll explain why that is in a second right there. So, it's not always necessary to avoid any kind of problems. So he's saying that he's running some problems by not initializing them. Not there. I get lazy and I don't always initialize it. There's no harm in initializing everything to 0 or strings to empty strings or something like that before you use them. Right? When you declare them, you can go ahead and initialize them to that there. It's a good habit. Back at Pascal, my first programming language that I really did a lot of structured level programming with, and I used it for a number of years when I was at Magnavox. I used a lot of my early programming. You couldn't initialize at that point. You had to go through and initialize it after you declared it. So we kind of got in the habit of not initializing. C introduced the idea of initializing them when you declare them, and us old Pascal programmers didn't always go back and develop that habit. Since you could do it, you might as well do it. Okay. Now, this here is one that is a good programming practice. I just said that I don't do it. He says to declare only one variable with each declaration and initialize it and provide a comment what that variable is being used for. That is an extremely good idea if you're writing code that's going to be reusable or go into production or it's not a one-time shot. I would strongly recommend you follow that. That's going back to this idea of num1, num2, num-sum. He declares it, he initializes, and then he puts a comment of what that variable is supposed to do right there. I said that I would probably just do num1, num2, num1, comma, num2, comma, sum, and be done with it. That's the lazy way, and it's perfectly fine to do it that way. This is the way that I'm supposed to teach you how to do it, right there. And I'm telling you that quite often I don't do it that way. Short programs like what we're doing in this class, you can get away with my easy way. If you're writing a 30, 40 page program that uses lots of variables, then you better darn well do it this way. And I'll be honest, when I've done real projects that have been 30, 40 pages, sometimes a couple hundred pages when we're all said and done with all the modules put into it, then we make sure we do it this way. So it's probably just a good habit to follow him and ignore what I do. Right there. So this is a case. Do they have that saying here? Do as I say, not as I do. When a parent's scolding you for doing something, they say, "Well, Dad, you do it." And then your dad looks and says, "Well, do what I tell you to do, and not what I do." My dad was pretty notorious for that. Quit your blankety blank swearing, as he's cussing at me while he's swearing. Well, Dad, you just used the same words I did. Shut up and don't do. Yeah, there, yeah. So, in other words, I'm getting scolded for doing what he just did, but he says it's okay for him to do it, but I can't do it. So that's what I'm saying here with this programming that there. I have a bad habit. I'm not going to break it, but try not to pick up my bad habit here. That there. Does that make sense? What that there? So that there. Okay. Now we're going into the fact that we've got double. Double is for specifying real numbers. That's things with a decimal point, right there. So there's also a type called float. The difference between float and double is that double is more accurate. It carries more decimal points. Float only uses 4 bytes, and double uses, I think, 64 bytes or something like that. I can't remember how many bytes they are. And it changes with compilers. That's why it changes with processors out there. So I know on the 8051 processor, when you use float and double, it's like 16 and 32. When you go to the Intel processors, that there, then it becomes like 32 and 64 bits. It varies on processors up there. But double is twice as accurate. It has twice as many bytes to store the number as float does. He chose not to mention float, but float is a legal term out there. Char is for character. Char is also used a lot in embedded for very small integers. Char is 8 bits, so you can represent a number between 0 and 255 out there. So out there, he does desktop programming where you measure your memory in gigabytes, and I'm using a microcontroller where I'm measuring my memory in bytes. There are microcontrollers that have got only 128 bytes of memory RAM available to us. That there, not a lot. That there. So you try to reserve space as much as you can and use the smallest data types out there. And that's the difference between a full-blown microprocessor and a microcontroller. Microcontrollers have very little memory attached to them. A char, again, is a single bit there. So these are the fundamental types he talks about: int, double, and char. We'll use that there. There's an appendix in the back of the book that contains a complete list of all the various data types. There's like 20 of them or so. Right now, the only 3 you need to know is int, double, and char. Int is for an integer. It goes between minus 32,767 to plus 32,666, I think it is, something like that. Char is used to represent characters, but it's also a number between 0 and 256. And double is any kind of floating point number right there. So those are the 3 that you need to know. Variable name cannot be a keyword right there. And you can use anything, a series of characters, letters, digits, and underscores. You cannot use dots. Dots mean something else. You cannot use spaces. You cannot use dollar signs and things like that. So basically letters and digits with underscores there, and you have to begin with a letter. So 1, 2, 3 is not a valid variable name, but I, 2, 3 is, for example. Now, C and C++ is case sensitive, so city is not equal to city right there. Because this has got a capital S, this has got a lowercase s. Those are 2 different variable names right there. So you have to keep that there. Good C programming technique is always to use all lowercase for variable names. In Pascal, we used to use uppercase for the first letter of every word, but now we've got C is almost always lowercase. So first name would be F name, for example, right there. You might see an old Pascal user use F name like that for first name. That is not a good habit to get into. That there, and we use uppercase for constants right there. So, right there. So, that there. C++ in Visual Studio allows you to have identifiers that are 64, 128 characters long. Why the bloody whatever you would want to use an identifier or a variable name that long, I don't know. I keep them as short as possible. That there. So, div C++ probably limits it to 31 characters right there. So that's the open source. It's probably limited at there. I would keep them to under 8 to 10 characters at most right there. Sometimes you run into some that are longer, but you don't really need to have that there. Now, a lot of times you'll find programmers like myself who started out in Fortran. We will typically do some things such as we will use I, J, K, L, and M, for integers at there and start that there, because Fortran required that. C has no requirement what you name anything, but some of us really old people. When I say old people, we're talking someone over the age of 50 that learned back on Fortran that they would probably use, because back then Fortran you did declare variables. But you looked at the first letter of the variable, and you're only allowed to have 2 characters for your variable name. So Fortran was very restrictive on variables. Life is much better today, and I took Fortran in 1979. I took Fortran. So that tells you how old that was. And I was probably one of the last students that used Fortran. Shortly after that, they switched to Pascal around 80, 81. So you're going back 35 years to Fortran programmers went to school. So that's why I'm saying someone over the age of 50 might have my bad habits right there. So when I do things like that, I'm telling you it's because old languages required that. So, right there. Okay, using meaningful identifiers to make a program self-documenting. In other words, num1 makes more sense over n1 right there. That there. So, first name is more descriptive than fn right there. So, in other words, use a few more characters and kind of outline that there. And if it's a student first name, you might put the word student in front of that student first name. If it's a faculty first name, or parent first name, parent first name right there. In other words, use variables that make sense in terms of what they do. That way you don't have to put 200 comments in there on what these variables are, and as you read your code, all right, what was fn? What was n1? What were these various ones? You'll see old Fortran users use something like n1 because we were restricted to 2 characters right there. You're not restricted to 2 characters. You can write a bloody book if you want to. There. Don't do it. I don't want to grade things with that there. And you don't want to go through and debug code with long variable names. But you want them long enough to know what they mean. Right there. Avoid using abbreviations. I use abbreviations right there. So if they're clear abbreviations, as far as what you, that there, in other words, STUD is clear for student. Right there. Unless you're talking about studs, which is when you build a wooden house, a stud is what they put between the walls to hold the wall up. Or if you're breeding horses, that's what they call a very, very fertile horse, male horse, right? A stud, that there. So that there. I guess that's a clean way of referring to it, but a lot of horse breeders use the term, that they're going to put their horse out for stud, that there, especially racing horses, right there. So. You do not use identifiers that begin with underscores or double underscores because take names like that underscore before the name of a variable is usually used by the library functions right there. So never begin a variable name with an underscore. I just treat that as a reserve, as reserved right there. Always begin your variables with a letter. Right there. And it's perfectly okay to use student underscore first name right there, instead of studf name. I don't use the underscores very often. I just tend to just run the words together, but he would probably prefer this versus me doing this right there. I'd probably put name there, right there. So if I was submitting a homework assignment, Mr. Dechtel or his son, and they were grading it, they would probably take points off for that, that there. So again, I've got some bad habits that this book encourages you to not follow that there, and I agree with the book for the most part, but that there. Okay. Declarations of variables can be placed almost anywhere in the program, but must appear before they're used, right there. That's just the rule. Remember, my rule is that I tend to put them all right there. Pascal used to require that all variable declarations are included in every function before the executable line, first executable line. So Pascal required that all variables are defined at the beginning of the code. So therefore, I picked up that habit because, as I said, that was my first there. I still think that it's a good habit right there, and I got to speed up. I've been chit-chatting too much right there. Okay, a prompt that there. We did the prompt here. Please enter your first number at there. So again, we use the stream to get the character from that and place it into the input stream. We did that already on our first one. But there, when executes an input there, it just places that. We've already did that. Here we did the number 1, number 2, so we're just going through that a little bit more detail right there. The end line, which is ENDL, several of you put 1 there last time, right there, is a stream manipulator. It just simply tells it to put in the end of line character there, and that's the end of our output, that right there. So, and then there outputs a new line and flushes the output buffer right there. If you leave the end L out there, the data may never be put out. It may be sit there in the output buffer right there. So you need to put that there. So again, that's in the library, so you have to use the standard library. And eventually, in the next week or so, we'll get rid of the standard. We'll talk about using that there. I don't know why he continues using it there. We can concatenate. In other words, we can have more than one right there. We did this with C out. That there, we had a string, we had our sum, and then we had our end line right there. So this here just simply concatenates that there. In other words, say one right after another right there is all that does. Then I can see, we just use the plus symbol for that right there. So right there. All right, this is what I'm trying to get across, and I got about 3 minutes to do it before our battery says I'm done. Right there. We have locations. A location has an address right there. In C, we don't care what the address is. If you're taking microprocessors, we would care a lot more about the address. So a lot of this you will see again in the your microprocessor course right there. So every variable has a name, a type, and a size, and a value right there. Now the size can be part of the type. In other words, int has a certain size right there, and you don't have anything. If you have a string, it can have 20 characters, 30 characters, 60 characters, whatever. That's a variable size right there. So if you deal with arrays, they typically have a size, and a value is what is stored in that location right there. So when a value is placed in memory location, it overwrites the previous value. That there. So it's said to be destructive right there. So it's a, when I store something that there, if I say N1 is equal to 5, whatever was stored in M1, or num, I called it num was stored in that location before is gone right there. Your name is Bill. You convert to Islam, your new name is Amin, Bill has been destroyed. You are now called Amin. That's what happened to me. My name used to be Roger many years ago. I converted to Islam. I went to the court and I said, my new name is Iskanda. So Roger no longer exists right there. So everything place I put my put my first name, I now will write the word Esconda because the old value is gone. I wiped it out right there. So we have a location right here, and this is the value right there. Now, this particular location actually refers to a address in memory right there, right there. But there, I will not get into addressing, memory addressing at this point right there. But this actually is a location in memory, and we got this huge place in memory right here, and we have all these memory locations right there. And whenever we declare something, what we're doing is we're going to say that this is now num1, and we're reserving this block of memory for that right there. In a microprocessor course, we worry about the locations. In the C course, we let the compiler just pick where it wants to put it right there. So again, these are just more memory locations right there. Arithmetic, we've already added. We've got multiplication. We got the modulus, which is the remainder after a integer division. So 5 modulus 2 is going to be equal to 1. Because 5 divided by 2 is 2 with a remainder of 1, right? So the modulus gives us the remainder. Here's what. My wife got really mad at me the first time I complained. When I had chocolate like that.
Oh.
That there and
Finished? Not yet.
no, hold on here a second. I got an issue here. My battery went dead.
Oh, right. Okay, no problem.
But there. All right, what's going on here?